In our last project, we mentioned that capacitors can store electricity. That means you can think of capacitors as being like the gas tank of a car. You can store electricity in a capacitor and then use it when you need it. This project will let you see how these electronic gas tanks work. Before you make the final wiring connection, be sure to set the select switch to A. Look at the schematic and you can see that in this position, current flows from the batteries through two 100 microfarad capacitors connected in parallel. Now, set the select switch to B. What does LED 1 do? As you saw, LED 1 glows for a few seconds and then goes out. This happens because LED 1 draws electricity from the capacitors until all the charge stored in them is exhausted. To recharge the capacitors, set the select switch to A for a few seconds. When you again set the select switch to B, LED 1 will again light. Do you think LED 1 will stay on longer if you let the capacitors charge longer? Try different charging times and try to find out. Do you think there is a limit to how much electricity a capacitor can hold? We've used μF to describe capacitors. That's short for microfarads. Farads are the units we use to measure capacitors, like we use ohms for resistors. Farads indicated how much electricity a capacitor can store, but farads are too big for use with electronic circuits, so most capacitors are measured in microfarads or μF, which is 1/1,000,000th of a farad, or picofarads, PF, which is 1/1,000,000th of a microfarad. Now that's what you call a small charge.
This has been a Cassette Master production.